So imagine we have a fixed shaft of 18mm diameter maximum size, so it's 17 plus or minus 1. And we'll have a second part with a hole in it, and we want to drop that part over that shaft feature. The shaft feature could be a bolt or a stud or something like that, but we definitely don't want to use that stud or shaft feature to control the location of the second part, and we're not trying to control the location of the shaft. We just want it to drop over it without forcing each part out of position. Now, in that case, the worst case is when that hole is at its smallest. And when that hole is at its smallest, that's called its maximum material size, in which case it's 19. If the hole has a position tolerance of 1, then the hole should still be able to pass over that shaft feature, even when it's at its smallest. And that hole could end up in a range of different locations, such as these, and in each of those cases it still passes over the shaft. And the thing that binds all of these possible locations together is they always clear this zone inside here, and we call that area there the maximum material virtual condition. So that space is never encroached upon by the surfaces around that hole, so the material never encroaches on that surface. We can now describe the functional limits that we've got from these parts as the hole must be between 19 and 21, and the hole must pass over an 18mm shaft at fixed location. So let's imagine the hole is now expanded out to its maximum size of 21mm in diameter. So the hole is now much larger than the 18mm diameter shaft, and even with its 1mm tolerance zone on it, all of those possible locations, it gives you a 2mm clearance. So the virtual condition of the hole has now expanded to 20mm in diameter. That's much larger than we actually need for the functional limits. If the hole is at its largest size, which is, we call that LMS, least material size, it has an additional 2mm of clearance, even with the position tolerance applied. So really, we could relax that position tolerance as that hole size increases, and it would still fit over the shaft. To indicate this, we need to use the maximum material requirement symbol, sometimes called circle M. Now this means that the geometric tolerance, our 1mm diameter here, only applies when we're at maximum material size, in other words when the hole is at its smallest. It also means that as this size increases from 19 towards 21, we can borrow some of the tolerance on the size and apply it to the position. So essentially, when this gets up to 21, this position tolerance goes up to 3. So let's see how that might look. So that 2mm of allowance that we've borrowed from the size tolerance, that's called the bonus tolerance. The indicated position tolerance applies at MMS, but increases with size. But the maximum material virtual condition stays the same. So we're always constrained by that 18mm diameter maximum material virtual condition. And we can essentially use that as a limit for any size and position tolerance combination within this hole. So technically, we're controlling the surface of the feature, not the axis. And we'll still meet the functional limits. So the hole must be 19 to 21, and the hole must pass over our 18mm diameter shaft at a fixed location. So there's our hole which is now a much larger size, and it's got a much larger range of possible locations. And there's our maximum material virtual condition. Now, it's really important that we recognize that the maximum material requirement is only to be applied to clearance fits. So never use it on an interference fit. We only use it to provide clearance around another part where the part location is fixed. Don't use it when you want to control location of the other part. Now the key point here is to think about the maximum material virtual condition, because it is that space that your hole does not encroach upon. When we're not using MMR, we have our functional size, 20 plus or minus 1, and we have our position tolerance of a maximum of 1 millimeter diameter. And that gives us these range of possible outcomes. So the hole size can be between 19 and 21, and the position can be between 0 and 1. Let's have a look what happens when you apply maximum material requirement. We're allowing that position to expand out. But all the time, we're thinking about the maximum material virtual condition of 18. So 19 minus 1 is 18. 21 minus 3 is 18. So this line is our maximum material virtual condition limit that we don't exceed, and we're restricted to the hole size. That's not taking into account this zone here, which also has a maximum virtual condition of 18. Now if you could, you might think about changing the size tolerance so that we still have a 21 millimeter diameter maximum size, allow the size to drop all the way down to 18, and apply this 0 for maximum material requirement. So this has a position of 0. How can you have a position of 0? Well, you can't unless you apply either the maximum material requirement symbol or least material requirement, and we're going to look at least material requirement in a moment. But in this case, you can expand down and include these possible outcomes, and again, we're not breaching our maximum material virtual condition of 18. We're applying everything that fits under that MMVC line.